Hello. Let's give one more minute for others to connect in case they're having difficulties with connecting. But thank you for joining. All right, I think it's okay to begin now. Good morning, good afternoon, good evening to everyone who are joining us today. Welcome to the Climate and Clean Air Coalition webinar on emissions from cooling systems in data centers. As we all know, life these days have become quite difficult to imagine without artificial intelligence. And it is the data centers that provide the vital infrastructure for AI. The refrigeration, air conditioning, and heat pumps industry have also started to use AI for fault detection, optimization of refrigeration systems and energy consumption, tracking of movement of refrigerants, etc. So much innovation is happening to help achieve sustainable cooling. But we should also not forget that storing and processing the required data the world needs is exponentially driving up the need for energy and refrigerants in cooling systems of data centers. This week there was the Artificial Intelligence Summit held in Paris, where the CCAC is hosted in UNEP. And we heard the world leaders loud and clear that there is an ongoing global race on AI. So we can definitely expect more and more growth. The IEA estimated that by 2030, just in just 5 years, the electricity demand for data centers will be equivalent to the current combined electricity use in the US and Europe. So that's really hard for me to imagine. There are also things that our community should look out for. On the negative, some data centers rely or plan to use methane for energy needs. On the opportunities, of course, you have the intense heat from data centers that can be rechanneled for use to those that need it. But today we are going to look at cooling. This webinar will help us better understand the issue and identify opportunities for countries, especially policymakers, to take early action to reduce current and future emissions from refrigerants and energy use. There are already many data centers in developed countries, but in developing countries, they have also started to multiply, and it is important that governments are prepared to help ensure the most sustainable technologies and practices to avoid increased emissions of HFCs and other superpollutants. So today I'm very happy to introduce our resource speakers, our experts on the issue to enlighten us. We will have Mr. Anderson Alves from UNDP, Mr. Bruno Lafitte from UNEP, United for Efficiency, and Dr. Daniel de Graaf from the German Environment Agency. We have allotted 75 minutes for this webinar. First, we will hear from all three presenters and then leave the Q&A and discussion after the presentations. But all of those that are connected, of course, you're welcome to ask questions and make comments. Also introduce yourself using the chat or the Q&A function throughout the webinar. So we will start with Anderson. If you would like to share your screen, Anderson. He is
Thank
the
you.
regional coordinator and senior manager for Asia Pacific of Montreal Protocol, and he will give us an introduction to the issue as well as zoom in on the China case.
Thank you. Thank you very much, Denise. I'm having problems to share my screen. I don't know if you need to unlock me in a way to share.
Let me share your slides for you if that's okay.
Oh, that would be perfect. Thank you.
And then you can just tell me to move to the next slide whenever.
Okay, great. Thank you. Thank you very much, Denise. Okay, so before starting with the presentation, I just wanted to place a little bit how I mean what I'm going to say here, which is basically in response to the kind invitation of Denise and the CCAC colleagues to present the problematic of the centers with the lenses of the recent project that was submitted on behalf of the government of China to the Multilateral Fund for the implementation of the Montreal Protocol. As you might know, there is now a funding window for energy efficiency while phasing down HFCs and data centers for what some countries more than others. It's a very relevant end user, not only because of the quantity of data centers that exist in the country, but most important because of the quantity of HFCs charged on this cooling equipment and the share of energy they consume. So next slide, please, Denise. Um, Next one, please. Yeah, it's just as this disclaimer of UNDP work in cooling. So I'm just going to dive in the issue that was requested to present. Basically, China developed this project and we assisted them to submit to the MLF in response to this funding window of energy efficiency. And it was considered in the December meeting of the EXCON, the 95 EXCON. And while revising the project, of course, it was important to make a connection between energy efficiency and reduction of HFCs. But one of the key arguments is that one of the questions that we received is that, look, data center exist in countries for many years, 15 years or so. And why just now we are discussing about energy consumption and the need of energy efficiency in data centers? So basically, we have to do a digression of what is happening to understand what is happening in the world and why the demand of energy in data centers is increasing so fast in the recent years. So as you can see here, in the past, the technology around the data center it was kept under a certain limit. It used to have CPUs with a power of 100 watts and GPUs with a power of 300 watts. But in the recent years, many developments in the area of IT happened. We have the whole boom of crypto mining, a movement of going deep in Internet of the Things in several applications. Many countries are starting to upgrade their networks to 4G, even faster cell phones that will require a large data processing power. And in the middle of all of this, we had the fast development of artificial intelligence, starting with the reading comprehension. Then the AI started to understand language and images. And now we are in the stage that AI is going through the predictive reasoning. And all of these require more data center and more processing power. And in the middle of this, we also have digitalization efforts from the public sector that is happening really fast, also as a response of COVID-19 and the needs to make the government more efficient. So all of this is pushing not only data centers to become bigger, but to become more dense and also their processing capacities to be much higher. For example, today we already have CPUs with power of 250 watts and GPUs with power of 450 watts. So you need more energy to run a data center than you usually needed before. And next slide, please. So under these conditions, if you take a typical data center that is a air-to-air type data center, you usually have that the computing processing power of the data center would require between 30 to 50% of energy. Cooling of these racks would require the same 30 to 50% power, while the remaining applications in the data center would require some 5 to 10% energy, which includes space cooling and heating for the people working it, water heating, lighting, and all the appliances that we have to make the data center park function. Next slide, please. Then it comes the technology we use to cool down the data center. Today, the dominant technology is air to air. So it means that basically you blow cold air in data center. This cold air will cool down the racks. So there will be a thermal transference, and the hot air that comes out from this process will be collected and cooled by a refrigerant unit. If we take a typical data center that has a load of 7,200 kilowatts of power, we are talking about an equipment, cooling equipment that would have roughly 4 tons of refrigerant inside. And we are talking here about metric tons. When you multiply it by the GWP of the refrigerant, and then you multiply by the quantity of data centers a country may have, then you easily are talking about hundreds of thousands or even millions of CO2 equivalent that are stocked only in the data center cooling units. Next slide, please. So when designing the project, we had to look into alternative technologies that could replace the air-to-air units with the aim to reduce HFCs, of course, because this is the target of the Kigali Amendment and hence also the main scope of the project, but at the same time reduce this energy demand that is growing a lot with the data center capacity. So the first alternative technology that could be used are basically the alternative technologies that are being promoted by the industry. Let me go back a little bit, is what they call liquid cooling technologies, where they basically, instead of being air-to-air type of heat exchange, in the middle you put determined cooling liquid that will improve this heat transfer. And by improving the heat transfer, you also improve the energy efficiency, because in theory, this technology would consume less energy. So the first one that we looked at was the non-contact liquid cooling. It means that the liquid doesn't enter into direct contact with the rack or the CPUs or the GPUs. This first technology is called cold plate. Is basically you design the rack in a way that you have a cold plate direct in contact with the CPUs, for example, or the GPUs. So this water will cool the plate, and then the hot water that leaves on the other side will be recirculated by the cooling tower and then comes back cool again, and this process continues and continues. But the problem here is that, as you can see from the diagram, you still need a refrigeration unit to remove the residual heat air that is in the system, right? So basically, you are not entirely, you are, for one hand, improving the energy efficiency of the cooling unit, but you are not entirely addressing the problem of the Kigali Amendment of the Montreal Protocol, that is reduce the demand for HFCs in the system. Next slide, please. So the second technology would be also a non-contact liquid cooling technology, but instead of cooling plates, you use heat pipes. The principle is the same. These heat pipes has a different design. They would be in contact with the CPU and the GPU in the racks, but the water or the liquid cooling, the liquid doesn't enter into direct contact with the IT equipment. The same as before, you can achieve energy efficiency in comparison to the baseline technology, but you still need a refrigeration unit to take care of the remaining heat load that stays in the data center. Next slide, please. Then we come to other types of technology that we call contact liquid cooling. In this case, we have dielectric fluids that enter into direct contact with the racks, with the GPUs and CPUs. So basically, it reduces the type of cooling of the liquid that we use. For example, we cannot use water anymore as we could use before, and also bring some additional technical challenges to the application of the technology. So the first one, which is one that is largely promoted by, for example, some big techs today, is the two-phase immersion cooling. So basically, it's a pressurized vessel where you have this dielectric fluid that enters directly in contact with the servers. So the servers will heat up, and this liquid will also heat up, will evaporate, and they will be catched by a condenser unit inside the pressurized vessel. This condenser unit will cool down the vapor, and which will precipitate, will condensate as liquid again. So basically, this process will continue inside this pressurized vessel. And outside in the you will have a standard water system that circulates through a cooling tower to cool down the condenser, right? So of course, in this technology, the one of the pro is that you completely remove the need for a refrigeration unit. So in principle, you don't use HFCs in the refrigeration unit. But the problem is that the dielectric fluid could be a liquid HFC. So you still may need an HFC in the system or a PFC, which from the CO2 side, the CO2 equivalent side, the GWP, is much worse. They usually have a GWP that is much higher than the HFCs. And there is an additional problem that you are talking about placing several pressurized containers inside a data center park. So basically, you had also to handle the additional risk of having several pressurized vessels working in your data center. Next slide. And the last technology would be the single phase immersion. And was the technology proposed by the project in China, which is basically you remove the pressurized vessel. You just have one single normal container where you going to immerse the racks, the servers, and then you have this dielectric fluid that will be responsible to change to cool down the system. So as there is no evaporation, the liquid will just continue run through this condensing unit between cold and hot cycles that will be cooled down by a water cooling tower outside the unit. So basically, in theory, you could reach much more energy efficiency with less drawbacks in terms of the technology applicability. For example, use of HFCs or PFCs, and there is no pressurized vessel inside the data center. Next slide, please. So the proposal of the China project was on top of using this single immersion technology, also to use this synthetic oil that has no GWP, zero, in comparison to other fluorinated liquids that have high GWP that are also used in this technology, as an additional environmental benefit to the project. So basically, we would go completely away from HFCs and then completely also meet the requirements of the Kigali, and that is to reduce the demand of these refrigerants. Next slide. So the project in China basically was designed on 4 big interventions. So the first would be to validate the technology itself in a large scale data center. The second one would be to do the relevant studies to assess the energy efficiency gains and any other potential environmental impacts that the project could bring. Review the standards, because if you can prove that this technology has much more benefits than the previous one, you could also place more ambitious standards for the new data centers that would be installed from the date. And of course, finally, disseminate the technology through training, through webinars, workshops, and knowledge materials, so other countries could also consider adopting. Next slide. Some additional environmental benefits that were proposed under the project, of course, was the data center would be placed outside the city limits, so we would also have less impact in the communities and the city itself. The waste heat from this water cooling process could be used to power a heat pump that would be also based in propane, that is a natural refrigerant, which would provide heat for the data center park. So basically, you would also require less energy coming from the grid to power all the heating needs for the data center. And also it was proposed a hybrid power supply technology in which 50% of the energy supplied to the data center would come off grid, which would also have additional benefits in terms of the overall climate carbon footprint of the data center. Next slide, please. So if you consider the theoretical model, based on the power usage effectiveness, that is basically the main metric used to determine the energy efficiency of a data center. This basically means the closer this PUE is to 1, the more efficient the data center is. So departing from the baseline technology, which is the air-to-air, as I mentioned, with 7,200 kilowatts of power, which has a PUE of 1.5. With this technology tested, we were hoping to achieve a PUE of 1.1, so which would be a huge increase in energy efficiency under those conditions. You can see the amount of energy consumption that would be reduced. So from 1,800, almost 1,900 gigawatts per hour to 1,300 gigawatts. And with additional benefits in terms of direct and indirect emission, because as you are not going to use HFCs or PFCs, basically you would not have emission of cooling liquid or refrigerant during the life cycle of the data center. And this also has additional benefits that are starting to be considered in energy efficiency standards for data center. For example, the level of noise. For example, if you put a data center with a number of cooling units, you have lots of noise being generated around from the condensers and cooling towers that also had some impact in the city and in the community around the data center. So all of these additional benefits could be factored in the renewal of in the revision of the standards if the project were to be implemented. Next slide, please. Oh yeah, so this is my last one. I'm sorry that I took more time than was assigned, and back to you, Denise. Thank you.
Thank you, Anderson, for the very good explanation for on the topic of data centers. Perhaps now I would like to ask Bruno if you can share your screen and let me know if you'd like me to share the screen. So our next resource person is Mr. Bruno Lafitte. He is an international energy efficiency expert for over 20 years, and data centers is actually really his specialization, and so he can give us additional information on what has already been presented by Anderson. Bruno, the floor is yours.
Okay, thank you. Thank you all. Can you see my screen? Yes.
Yes, it's not in presentation mode yet. So if you
Oh,
can,
okay. It is on my screen, but okay. I try again then. Okay, I stop sharing. I will share my my screen. It's can you see in presentation mode?
Yes.
Yes. Okay, perfect. So thank you for this webinar. That's very interesting, and thanks a lot, Anderson, for your presentation. Very informative. I'm Bruno Lafitte, working for UNEP at United for Efficiency. As you will see, we are dealing with efficiency on lighting motors, refrigerators, climatizers, and so on. Sorry, but also in data centers and more than efficiency. So here we are talking about data center and computer servers for sustainable digital market transformation. You will see we did release a document, a sustainable public procurement guideline on that topic. But what is the situation worldwide? Well, on this audit, we need it for sure. We need data centers for everything, for data. When we are using internet, we are using data centers every time. So but it's highly energy intensive, and the share between IT consumption and cooling. Cooling can be the primary is for IT, of course, from 40 to 70%, but cooling has also significant share of energy consumption in data centers. I will go quickly. If the internet was a country, it would be the sixth biggest electricity consumer in the world. This is an old picture. Now I guess it will be more actually, because we've seen a surge in data centers energy consumption in recent years. We say several thousand large-scale data centers exist worldwide. And also a lot of hosted servers in enterprises, small data centers. I'm sorry, that window is okay. It emits 200 to 250 megatons of CO2 annually. I guess now it's even more of CO2 emission, and most importantly, the use phase is emitting more than the other phase of the life cycle assessment of data centers. Actually, that's what study says. So data centers in the world are consuming 460 terawatt hour in 2022, and the International Energy Agency thought that it could double by 2026. Actually. So we are talking about electricity, about CO2 emission, but there's also issues on water. For an example, in July 2023, the Greater London Authority said, okay, we are using electricity for data center. We cannot use it anymore for building new houses, but also said that data centers are using too much water. The Thames Water Company in London says, okay, you have to make a plan to reduce your water consumption or to reduce your data center activity, because now you are using too much water, and we need water for people. That happens also in Chile, in other countries. In Ireland, a fifth of Ireland electricity is consumed by data centers right now. So there's big issues, and those are developed countries. You can find those issues even more in developing countries. So this is worldwide. Now in Asia Pacific region, I put two picture here to have a flavor of the growth of the power that is installed for data center. And power comes with cooling, of course, because when you have more power, you have more power for IT equipment, so you have more heat that is generated, because when you are using electricity in IT equipment, this is converted into heat at the end, and you need to dissipate it so servers can operate properly. And that's why you need cooling. But Anderson told it very well. when you look at the picture, so this is excluding Japan. This is from IDC. You see the growth rate in power. This is quite impressive. Here it's about 50%, 50%, and in 5 years, so it can reach nearly 100,000 megawatt per 2028. So that's quite impressive. And here you see the dynamic also. You see the growth rate, but in the region except Japan. But here you see the dynamic for different countries. So mainland China, sorry, you have from 2023 to 2026 is expected a growth rate in power installed of 35%. And you see this is increasing everywhere. In India, that's quite impressive. 89% more power for data centers in 3 years. But look, in Malaysia, it would be 185% more power in 3 years. In Indonesia, also, that's quite impressive. You see, in Thailand, also, that's increasing a lot. But all numbers are big. In South Korea, also in different countries, all numbers are quite big. So let's move to the next slide, talking about sustainable energy challenges. Energy. This is more than energy, and so the second highest energy consumption is for cooling. We told it. This is because electricity is ending up in heat, and we need to dissipate it. We told it, and Anderson did explain it. But also, depending on the cooling system of data centers, you are using more or less water. And when you are using water, it's not water from the rain, it's water from the tap, basically, because you need clean water. And that's why I told you in the introduction, that's why in London, but also in Netherlands, for Europe, but in Chile, in Brazil, in some countries, you had some issues with water. And also, please keep in mind that most data centers are claiming that they're using 100% renewable energy, but you must be aware that this renewable energy can be used also for other purposes. So we must be sure that they don't monopolize all renewable energy inside the country. The example from Anderson was quite great, because as far as I understood, 50% of renewable energy will come from off-grid renewable facilities. So that was a very good example. What we did develop, knowing that background and against it, we did develop sustainable procurement guidelines for data centers and servers. This is intended for public procurers first, technical personnel, policymakers, officers involved in procurement activities. But it can be broader. You will understand why. The scope is data centers, so we will give some recommendations, some KPIs on data centers, but also computer servers and data storage products. We did develop those guidelines in a consultative and collaborative process, let's say. We did consult a lot of institutions, the big ones in data centers world, Uptime Institute, the Green Grid, but okay, we just had discussion. They didn't approve everything, but we did discuss, and we discussed with the Uptime Institute, France Data Centers, the French Alliance, but also Equinix, which is a worldwide big player, Google, Microsoft, LBNL, IBM, and so on. So lot of institutions. The general content, it's a simple set of recommendations technical requirements to consider for procurement process to ensure that you are buying a sustainable and efficient data centers or servers by itself. How to use it? Either you use it to select or to approve where to host your data. If you want to host public data from the government, you have to select a colocation data center if it's not yours, and then you can select it based on those recommendations, and other you can use it also to approve new data center facilities in your country, because you have to give your yes, you have to approve it, and then you can ask for the data center operators, okay, but what about PUE, what about water, what about cooling effectiveness ratio, what about everything? So you will see a lot of criteria you could ask. A lot of criteria. So in the guideline, you will find performance criteria for data centers and computer servers. So this is in blue. And here you have KPI. So Anderson did mention the power usage effectiveness, but this is one KPI that is widely used. But you have also water usage effectiveness. You have cooling effectiveness ratio, IT equipment energy efficiency for servers. You have server efficiency, data storage efficiency, and so on, idle state efficiency, and so on one side. The other side is operating conditions. So location of data center, where it is located, it is where you can benefit from river cooling, for an example. This is or free cooling or renewable energy. So you have the renewable energy factor, the resilience of data centers, that is key for data centers operator. Modularity, cooling design, operating temperature, humidity, CPU, and utilization rate of IT equipment. This is very important, because when you think about data center and servers inside, they are used in average 30% of the time. 30% of the time, it means that 70% of the time it's not used. It's in idle state, ready to be used. So you can when properly managing this, you can lower the numbers of servers. That's important also. And you have also lighting, motors, refrigerant. We are talking about refrigerant used for cooling and so on. So on all those criteria, we did select 5 of it. This is KPI, key performance indicators, and you have ISO standard in front of it. So how to measure it? It's simple, following ISO standard, and I'm a member of the ISO committee, so I know that they were updated very recently. So you have PUE, WUE. This is for electricity. This is for water. This is for renewable energy. This is for cooling effectiveness. This is for what I told about utilization ratio, and you have value, real value in front of it. What you could expect from a good data center in 2025, 2027 until 2031. Okay, so you have a roadmap, and you have it for okay, let's say normal country, but also for hot and humid climate. This is corresponding to those climate zones. So you have different value, because you cannot do a lot of free cooling. Let's say you open the window to cool your servers. It's not exactly like this, but okay, you understand the principle. So you have a different target value for hot and humid countries. You have also values for data center, for new data center by design. It means that they claim they will reach that value. This is by design, but actually they don't reach that value before 5 or 6 years of operation for the best case. So you must ensure they are on track. So you must ensure that after 3 years of operation, okay, you didn't reach by design value, but you are on track. So you have here the value that they should obtain after 3 years of operation. and you can check it. This is easily checked. This is something that is asked for an example for energy staff for European directive. So these are not unknown KPI and very hard to measure KPI. That's wrong. Okay. So next slide. We have also based on those KPI, we did develop a kind of award criteria or labeling. You can use it as you wish, but here you can find the 5 KPI and you have different score based on the value that you get, and you can combine those KPI to get one score for the data centers, and you can apply different weighting for those KPI depending on your country and the interest of your country. Do you want to reduce water consumption or electricity? Do you want to emphasize renewable energy use? Or so you have those values here, and one metric, one score per data center. You can use it either for selecting between different offers for new data center. Okay, you have here 2 scenarios to use it as public procurers. So scenario 1, you have to set very hard criteria, and once the offer is okay with the criteria, you select the lowest price. This is one way of doing. The scenario 2, you can have different score for different criteria, and you select the best. Okay. So now if we focus on cooling more precisely, and we are coming back a little bit, for cooling, the best practices is, Anderson did talk about it, but you can increase the temperature range of server, you can arrange your IT room design, segregating hot and cold areas, you can increase the efficiency of existing cooling, change the cooling system to liquid cooling, or immersion cooling. It's even better. We saw it. Change the refrigerant to one with a low GWP, increase the use of free cooling. You can also increase the effectiveness of pumps, fans, and compressors that are used. The benefits, this is average numbers, let's say, but the benefits from data center green regulation will be to reduce energy consumption, reduce water usage, expand internet access also, because in developing country, the internet access is more expensive than in developed countries. That's crazy, because you are using data centers in let's say California or China or elsewhere, but you want to have your own data centers and lower price for internet access. You can increase the use of renewable energy, foster waste heat reuse. Anderson did talk about it. That's very interesting, to reuse waste heat, lower material impact, and control the country's development by lowering the impact of data center on the grid. And we've seen it's quite important, and water supply. So thank you. Hope I didn't spend too much time, and I keep here for questions. Thank you.
Thank you, Bruno. That was really interesting, and also gives us a bigger picture of, the data center stories. Danielle, if you can prepare your next your slides, if you can share it, or let me know if you have issues with sharing your slides. Okay, so our next presenter will actually give us firsthand experience on how Germany has been their experience with data centers, and what they're doing to reduce emissions from data centers. Daniel, you have the floor. We don't see the slide show yet. It's not yet in slide mode.
Okay. Um, says it's already shared.
Yeah, we can see your slide, but it's not in the slide mode, like slide presentation
In a
mode.
presentation mode, you mean?
Yes.
So can you see it now?
No, can you try again?
Sure. Sorry for that. Once again. Oh. Can you see the slides now?
Yes, we can see the slides.
Okay, brilliant. So thank you very much to Anderson Alves and Bruno Lafitte for the introduction and the details on how data centers are set up and work, and how much energy and refrigerants they use. And well, it's quite significant consumptions of energy and of refrigerants and hence emissions, but you can do something about that. And Germany did that, and I will just share with you some of the experience with data center cooling emissions and the respective reduction measures. So this shows you, this graph shows you how much energy is used by
Sorry,
the state-owned.
Daniel, it's
Yes,
not in the presentation mode. If you want, I can share it, and then you can just tell me to move to the next slide.
okay. I'm sorry
Yeah.
for that.
Okay, go ahead.
Okay, brilliant. Thank you, Denise. So here in this graph, you can see the power, the energy consumption of the state-owned data centers in Germany. And you can see that significant reduction could be achieved starting from 2008 with power consumption of 650 gigawatts hour. And this went down to 344 gigawatts, so minus of 47%, almost halved the power consumption. And this could be mainly achieved by consolidation measures. Next slide, please. So beyond these measures, there are new obligations, not only for state-owned data centers, but for all data centers in the European Union, because it's an implementation of an EU directive where these obligations stem from. It's the EU directive on energy efficiency. And within the scope of this directive are data centers with a connection power of 300 kilowatts and more. And they have to use a certain quota of renewable energy, which is 50% and 100% by 2024 and 2027, respectively. There have to be minimum energy standards fulfilled in existing data centers, which is a PUE, a power usage effectiveness of 1.7 from July 2027, and a PUE of 1.3 from July 2030 on. PUE, as Anderson, Alves, and Bruno Lafitte put it, is, or already explained, is the data center energy consumption, which includes the cooling energy consumption, divided by the IT energy consumption. And this ratio is the PUE. And for new data centers, there's also a limit, which is even more ambitious. They have to fulfill a PUE of 1.2. Also, they have to utilize their waste heat 10, 15, and 20% from July 2026, 2027, and 2028. 8 on, respectively. Next slide, please. So when we talk about refrigerants in data centers, we wanted to know what kind of refrigerants are used in Germany. And so we had a small survey among consultants which help data center owners to commission their data centers. And you can see here that for older data centers, it's the, so to say, incumbent HFC refrigerants. We all know R134A is one of the most dominant, or R410A, which was also given in the example by Anderson Alvers. And if we come to new data centers, which have less than 5 years of age, this shifts to hydrofluoroolefin, HFO, refrigerants and their blends. But you can also find data centers which run on natural refrigerants such as propane and ammonia. We have data about HFC emissions in Germany and Europe, but there are no specific data on the emissions from data centers. They are not available, unfortunately. Next slide, please. So I just presented to you the obligations by certain policies and laws, but you can also do, as a data center owner, voluntarily something about your energy consumption and the use of refrigerants. We have a eco-label in Germany. It's called the Blue Angel, and there are criteria also for data centers. And as I said, it's a voluntary and market-based label, and it sets up requirements for the IT, so for the servers, and the technical building equipment, including the cooling system. So for the cooling system, there is the cooling efficiency ratio, which was already introduced by Bruno. And this is calculated by the heat, which is dissipated, expelled to the ambient, divided by the energy of the cooling system, which you need to do that. And this cooling system, or this cooling efficiency ratio, needs to be greater than 9, which is a quite ambitious value for the new data centers commissioned in January 2024 or later, and it goes down to value, CR value greater than 5 for the older data centers, which have been commissioned in December 2014 or earlier. There's also an obligation for the data centers regarding the refrigerants. They need to be halogen free, so no HFCs, no chlorine or fluorine in the compounds used as the refrigerant if they were put into operation before January 2013. And these criteria, so all of them, are need to be applied by the state-owned data centers with IT capacities of more than 100 kilowatts. And if you are interested in these criteria, we call it basic award criteria, you can look them up under the link given here below. Next slide, please, Denise. So I wanted just to go a bit more into what kind of refrigerants should be used. And many experts also argue that in order to deal and to comply with the Kigali Amendment and to reduce HFC emissions, we should introduce HFOs, but there we have quite severe environmental problems which go along with the use of these refrigerants because of the one hand side, They have a low GWP. I gave that before in the table. It's 1.37. That's really low. But the problem is that these compounds are broken down in the atmosphere, and they form, on the one hand side, fluoroform, which is HFC 23. So with this also in the atmosphere, that gives an effective GWP of not 1.37, but this is much higher. These guys, Perez, Pena, and others, estimated that it's around 266, so much higher. And on the other side, another breakdown product of HFO refrigerants such as R1234YF and ZE is trifluoroacetic acid, TFA. And this compound is a so-called PMT compounds. PMT stands for persistent, mobile, and toxic. And the mobile trait of character, so to say, leads to the problem that it cannot be removed from drinking water. So it's broken down in the atmosphere, HFOs. They are gathered by the rain and in the surface waters and hence in drinking water. And when it's in the drinking water, then it's also in the food, and you can find it in humans, in the blood, in urine, in beer, in food in general, etc. So it's quite a big environmental issue. And the main entry of TFA are indeed HFO refrigerants, and so it cannot be seen as an environmental sound solution. So next slide, please, Denise. So we think the German government has the position that only natural refrigerants are really up to deal with the Kigali Amendment and provide an environmental sound solution. And here, on my last slide, I brought you two examples where a big and a smaller data center are cooled with natural refrigerants. This is on the one hand side in the south of Germany, Neckarsulm, and that has an area of 2,000 square meters of white space, 5 megawatt of IT, and a cooling system of 6.6 megawatts. And the refrigerant is ammonia in this case. And for very small data center on the right-hand side, I would even call it a server room, is cooled with 2 times 12 kilowatts of cooling with an R290 cooling plant. And as you can see, it's an outdoor installation, but equipped with a gas sensor if in case of a leak. And you have the option there for free cooling, so you don't need a compressor and can save a lot of energy. Next slide, please. Thank you very much. That was the last one, and I'm happy to answer your questions.
Thank you very much, Daniel, for that very good example of actually we're not hopeless, that there's things already, there's experience already. And I think, a lot of those that are connected here are policymakers, Montreal Protocol, National Ozone Officers, as well as, representatives from the governments of the Climate Engineer Coalition partner countries. We did have like some questions in the chat, but I think during your presentations, most of them were responded to. But perhaps I'd also like to invite Soledad, who works with Bruno in United for Efficiency, and maybe ask her a first question. Soledad, are you there? Can you hear me?
Yes, I hear well, Denise. Hello
Yes.
there.
Thank you. Thank you, Soledad. So I actually wanted to ask you, Soledad, from your perspective as, as from UNEP, what does all of this mean? What does it mean for policymakers? What can we do at this moment, upon hearing this important issue?
Sure. Thanks for the question. And all through presentations highlighted, I don't want to say the word issues, but aspects on data centers that could be improved through different measures. And here policymakers can have a huge impact, and there are different areas of intervention. The first one could be the development and implementation of standards. We have noticed that most countries doesn't have any standard that regulates the market of the data centers in their country. Only very developing countries have this, and even the European Commission is now working on there. So there's a lot of there's a huge potential there to regulate the market and make sure that the new data centers that are going to be built the next years comply with energy efficiency measures, that comply with waste used, with the renewable, and so on and so forth, like Bruno mentioned, the KPI. Another area where policymakers can intervene is on the waste management. As any other product, data centers have the ICT equipment and cooling systems that at the end of the life need to be collected and disposed in a sustainable way. So here, policy frameworks are key. Also for the refrigerant life cycle management. So this is a linkage also with the mandate of CCAC. So this is a huge area where policymakers can also intervene. Another area is data and the assessment on the energy consumption, water consumption, and so on and so forth, because something that we have noticed also, there's a important there's a lack of information on data centers. The market is not that transparent, so there's a lot of room to make interventions on regards of measures, on regards of the assessment of the consumption, on the policies to extract that information, to collect that information. So these are just a few areas where countries can do lots of things to improve the market and to make sure that the upcoming data centers are sustainable.
Yeah, and the guideline that you had produced, can you let us know when it will be available to share to everybody?
Yes, we are just finishing the publication process from UNEP, so we hope that this is available on U4E's website in the upcoming weeks. But in the meantime, and for the sake of those that might be wanting more information, we're going to circulate a summary with the key recommendations from the guideline that Bruno presented as well. So yes, this is upcoming. In a few weeks.
Thank you. I think it's very badly needed how to do this actually. There were some questions in the chat. I'll just read some of them. From Christina, I think this was answered by Daniel while he was presenting our natural refrigerant-based technologies being considered for data center cooling. And yes, and I think the message was clear, but how feasible is it for developing countries to access? Maybe I will ask Daniel if you have any comments.
So yeah, I don't see any problems to to supply these technologies also in developing countries. So if you deal with HFOs, which are flammable, for example, then you can also deal with propane, which is a flammable refrigerant, or with ammonia. Of course, the personnel needs to be trained on these refrigerants and know what they are doing. But this is not something which only works in developed countries. And we have also a lot of examples from developing countries which apply the natural refrigerants.
Thank you, Daniel. And there was, go ahead.
Yeah, sorry. Go ahead, please.
No, I was just going to say that there's also a question on bans or restrictions for HFOs in Europe, and maybe you can respond to that in the chat. And maybe in the meantime, I actually wanted to ask Anderson and Bruno if you can both respond. So in terms of the technology needs, because indeed there are like some things to do, but is it enough? I guess not, because we want to propose more. And I think, people are also wondering, about the issues with deep sea, wherein maybe the energy demands or the environmental impacts are not going to require the same things. Do you have any comments on this? These are my personal thoughts and questions, but I'm sure that others have like shared the same, curiosity.
Anderson first.
Well, before any reflection, Denise, I just want to recognize that we have here in the call Ms. Li Xiaoyan. She's from FECO, from China, and she was instrumental in designing the project. So maybe she can also jump in terms of technology selection and explain why, for example, why China decided to consider these and not the other cooling technology when it comes. So Xiaoyan, please jump in if you want and if you need. But I think that for developing countries, the technology choice, of course, it's maybe a little bit more complex because in one hand, as Bruno and Soledad said, lack of standards. So the ambience is not conducive for certain type of technology because basically you don't have a policy behind that can push, right? So it makes more difficult for the owners of data center to go for this or that technology without a requirement. But also, and it's not different from any other cooling solution in the Montreal Protocol. When we talk about flammable and toxic refrigerants, the chargers are critical. So, for example, when you talk about retrofitting a data center, you need to consider if it is worth, because there is the issue about the life cycle of the data center. Maybe it's not worth to invest thousands of millions of dollars in a retrofit in a data center that will be obsolete in few years. Because if you use a large charge of, for example, we consider that charge that I mentioned, 4 tons of 410A in a standard data center. Even if you go for propane that has a small molecule size, meaning that in theory, you need less charge to achieve the same cooling performance. So you are talking about maybe 1 metric tons of propane to deliver the same efficiency. But it's still 1 metric ton in an old design that may not be conducive for safety. So all of these considerations are very critical for developing countries when choosing the technology. And one question mark that also I thought a lot and could not answer, and this came from the Secretariat when they were revising the project, is that, okay, if you have all these technologies that you could use, why data centers are not using more liquid cooling because the technology is there. So I don't think that I have an answer now. Maybe something that is worthwhile looking into the key IPs of the countries when doing the surveys and etc. But could be related to cost, could be related to cost of installation, meaning capital cost, could be related to availability of these technologies, could be also the lack of standards that don't push for them. So there are many questions that we still need to investigate to consider when making policies around it. And as I said, Xiaoyan, please let us know if you want to complement anything or correct me. Yeah, thank you.
Xiaoyan?
Oh,
Am I?
sorry.
Yeah, my name is Xiao Yan. I'm from the Montreal Protocol Division of FECO, China. I want to thank Anderson for introduce this pilot project in China. I just want to highlight a few advantages of this liquid cooling technology China has selected. Firstly, I think this is, as Anderson mentioned, this is one-phase cooling technology, liquid cooling. In general, China now is promoting liquid cooling instead of air-to-air systems. As I noticed, Daniel introduced that the R290 and ammonia can be used to replace HFCs. However, there are safety concerns, especially for Asian countries with high population density. And also this air-to-air system have a much lower efficiency compared to the liquid cooling. And for this specific technology we identified, I think this system is quite clean, and the investment now is not very high if we compare to air-to-air system. And this blend, this liquid, it's not toxic, and it's no potential harm to the environmental and to the environment, and the liquid is actually recyclable. And also for this technology, I think it have some other advantages, as it will save a lot of land. As for traditional data center, this technology can only need 1/10 of the land. And then if we add renewable electricity and also PV panels to the data center, we can also install batteries to store electricity. Then this whole system can be carbon zero or even carbon negative. So that's why China now is promotion this kind of a liquid cooling technology. Thank you.
Thank you, Xiaoyan. That's very interesting, and maybe we want to hear more later on. So Bruno, go ahead.
Yeah. Just one word. Yeah, that's very interesting. Thanks a lot, Xiaoyan. That's very interesting project. Just to be clear, carbon zero, just on use phase, not on construction phase, and yeah, but that's still very interesting. This is immersion cooling, and this is at the top of the cooling right now. When we talk about liquid, so this is we have very few examples that works worldwide, but for developing country, I guess immersion cooling is quite hard to maintain or to find skilled people and so on. But when we talk about liquid cooling and direct liquid cooling, this is a bit different, but Anderson did explain it. This is bit more simple, but you must keep in mind that even if you're using direct liquid cooling, you still need air cooling. Because traditionally with direct liquid cooling, we tackle 70% of the heat, but you still need to dissipate 30% with air cooling. Because liquid cooling, traditional liquid cooling, you are cooling CPU, you are cooling GPU, but you have other parts of the servers that are still needed to be cooled. So that's one thing, and why it's not widely developed, yeah, because of the cost. You're right, on this one the cost is there, but also because of maintenance, and yeah, because you still need two systems at the end of the day. So sometimes it doesn't worth it to and for an example, Microsoft is a quite big company, let's say, and they did build a whole data center with a traditional cooling system, And but I realized with IA and so on, the density is so high that we need to go for direct liquid cooling directly or immersion cooling. And they did decide to debuild the whole data center, to rebuild a new one with that kind of cooling. Okay, but that costs a lot. Microsoft can do that, but yeah, not everybody can do that.
Thank you, Bruno. And there's still a lot of questions on the chat, but unfortunately, we are already over time. We extended it for 15 minutes, but it's interesting and we can speak and go on and on. But I think it has been really good presentations, and there is so much more to learn. For those who had asked the questions, we'll try to respond to your questions in writing. And just to thank all our speakers today for sharing your knowledge, and for the ones that joined our call. Of course, you are welcome to participate in further webinars and discussions. You can contact us in the Climate and Clean Air Coalition Secretariat, because we do consider this as something that everyone should be paying attention to, and we would pursue with more awareness raising and sharing of information and knowledge. So thank you very much again. I'd like to also thank my colleagues that join and support us, and wish you all a wonderful day or evening wherever you are. Thank you so much. Have a nice day. Bye.
Thank you. Bye.
Thank you, Denise. Bye.
Thank you. Bye.
Bye. Thank you.